Now, what is this dehydration reaction? Now, the dehydration reaction happens when you have a substrate that usually has an alcohol group on it. So this right here is our alcohol group. And when you supply it with our sulfuric acid with heat, what ends up happening is that a proton from sulfuric acid, so one of these protons right here, gets donated to our alcohol group. And so we get an intermediate right here with oxygen with two hydrogens, and therefore it has a positive charge because it only has one lone pair and three bonds. Now this water group is a very good leaving group, and so it will leave on its own. What it'll do is it'll take the bond that it has to the carbon on its own and form it as a lone pair, and so now we get a carbocation. And so we have a carbocation on our substrate and a water group floating around. Now sulfuric acid over here, let me just write it out, is now the negative conjugate, the base conjugate, is a terrible nucleophile. This is a horrible nucleophile. There's no way it's going to undergo an SN1 mechanism and go to the carbocation and do a substitution. What it'll in fact do is act like a base, a weak base, but also act like a base, and it will attack this hydrogen right here, and basically this bond that we have to the hydrogen will move and form a double bond with this carbon on the carbocation. And so we get our E1 product right here. Now this product is now the major product, and the reason it's major and not the substitution being the major is because sulfuric acid is a very, very, very bad nucleophile. It's more likely to act like a weak base rather than a nucleophile. Now, what happens if sulfuric acid is too dilute? What if we have another nucleophile in the situation? We're still going to get that same intermediate where we have our carbocation because the OH group got a proton donated to it, and it leaves as a water group. But methanol, although it's a bad nucleophile, it's better than sulfuric acid as a nucleophile. And since SN1 mechanisms are usually the major product naturally, it's going to attack that carbocation, and we're going to get our SN1 product right here. Now, we're still going to get our E1 product naturally, just because it can still act like a weak base. But now our E1 product is no longer our major product. And so, generally, when we're doing a dehydration, we want to have a substrate. Usually it has an alcohol, and we want to give it with only sulfuric acid and some heat. And that way, we can ensure that we get an E1 product as the major product. And so, that is the dehydration reaction.